Heat project. Heat versus temperature. Heat. Heat is the transfer of kinetic energy from one medium to another. Temperature. Temperature is how hot or cold something is. Temperature is caused by heat, but they are not the same. Celsius versus Fahrenheit versus Kelvin. Celsius. 0 degrees Celsius is the freezing point of water, with the boiling point being 100 degrees. Fahrenheit. For Fahrenheit, the freezing point 32 degrees with the boiling point as 212 degrees. Kelvin. For Kelvin, the freezing point is 273 degrees with the boiling point as 373. Celsius and Fahrenheit are used often in daily life for things such as cooking. On the other hand, the Kelvin scale is commonly used by scientists since it is an absolute measure of temperature and is directly related to kinetic energy. Types of heat transfer mechanisms: conduction, convection, and radiation. There are 3 types of heat transfer mechanism, and those are conduction, convection, radiation. Conduction is when 2 modes of heat come in direct contact with each other. Example: eggs in the frying pan. Convection is the same thing as conduction, but it is when 2 modes of heat, liquid or gas, come in contact with each other. Example: cold breezes. Radiation is the energy that travels through space at the speed of light. Example: X-ray. Dissipation of heat. Dissipation of heat is when heat from an object source gets transferred or moved into its surrounding environment. This can happen in 3 different ways: conduction, convection, and radiation. Dissipation is when energy goes in different directions to get lost. Sea and land breeze formation. Sea breeze. Sea breeze flows from sea to land. Land breeze. Land breeze flows from land to sea. The sun heats up both land and water, but the heating between them differs and sometimes cools in different places. In short, this is what causes the breezes. Conservation of energy. The law of conservation of energy states that energy can neither be created nor destroyed, but can only be converted from one form to another. According to the law, though we can't use up all the energy, but neither can we create it, so we use appliances like windmills or dams to harness energy from water, air. Phase changes. Conduction, gas to liquid, A. Boiling, liquid to gas, B. Freezing, liquid to solid, C. Melting, solid to liquid, D. Sublimation, solid to gas, E. Deposition, gas to solid, F. Kinetic theory. Postulates of kinetic energy. The molecules in a gas are small and far away from each other. Most of it is empty space. Gas molecules are in constant random motion. Just as many molecules are moving in one direction as in any other. Molecules can collide with each other and with the walls of the containers. When collision occurs, the molecules lose no kinetic energy. That is, the collision are said to be perfectly elastic, unless there is some interference with it. The molecules exert no attractive or repulsive forces on one another except during collision. Between collision, the molecules move in a straight line. How to measure heat and temperature. Heat. A thermometer is used to measure temperature. The device used to measure heat is called a calorimeter. Room temperature, 0 C. Temperature of a healthy human body, 296 K. Boiling point of water, 98.6 F. Temperature. A measure of the average kinetic energy of the particles in an object is called temperature. When it increases, the motion of the particles also increases. Temperature is measured with a thermometer or a calorimeter. Idea of calorie. A calorie is the amount of energy needed to raise 1 gram of water by 1 degree Celsius. You will often hear about calories in relation to food, and sometimes as a bad thing, but really, the amount of calories a food item has is the amount of energy it contains. This also applies to non-food items, but food is a prime example. Idea of calorie. A calorie is the amount of energy needed to raise 1 gram of water by 1 degree Celsius. You will often hear about calories in relation to food, and sometimes as a bad thing, but really, the amount of calories a food item has is the amount of energy it contains. This also applies to non-food items, but food is a prime example.